Hi, in this video, we're going to be looking at some more examples of solving problems involving Newton's second law. Specifically, we're going to look at some vertical acceleration problems. So example 4 here says a 55.0 kilogram skydiver named Holly is falling straight down toward the Earth. At one point in her descent, the air resistance she encountered was 295 newtons. What is her acceleration at this moment? So we're going to start by drawing a picture, then identifying the forces that are acting on the skydiver. In this case, force of gravity is pulling the skydiver towards the Earth, but there's also some resistance because of air resistance. So that air resistance is acting up. Now, I don't know if that air resistance should be greater than the force of gravity or equal to the force or less than. So I'm just going to draw it right now, and we might have to come back later and adjust this arrow so that it's greater than or less than or equal to. For now, we can at least say the horizontal net force. There's no forces in the horizontal direction at all, and so there is no horizontal net force. The vertical net force is going to be the air resistance plus the force of gravity. Those two would be equal to the vertical net force. So what are we given in this case? We know that the mass of the skydiver is 55.0 kilograms. It says the air resistance was 295 newtons. So air resistance, 295 newtons. Is that going to be a positive or negative value? Force is a vector, so we have to pay attention to the direction. It's going up, and so we call that positive. So positive 295 newtons. We want to know what her acceleration is. That's our unknown, right? That's what we're trying to find. Using Newton's second law, if we're trying to find the acceleration, we need to know the net force and the mass. We know the mass already. We know that the net force is the air resistance plus the gravity down here. One thing that's easy to forget is that we can calculate how much gravity is pulling down on this skydiver because, if you remember, there is an equation that says the weight of any object is equal to the mass of that object multiplied by the acceleration due to gravity. And so the weight of the skydiver is 55 kilograms times negative 9.81 meters per second squared. So we put that into a calculator. 55 times 9.81 is 539.5. So we're going to round that to 540 for the skydiver's weight, and that's in the negative direction. So this is not what we were asked to find, but we found part of the net force. We already know the other part of the net force, the air resistance. So now we can find the net force acting on the skydiver. Why do we want to do that? Well, remember, originally we're still trying to find the acceleration right here. The acceleration is equal to the net force over the mass. So we want to find the net force so that we can find the mass. So let's just solve it right here. I'm going to draw a line right here to separate my work. So we're just focused on the right side here. I can't draw a straight line, but that's okay. So I'm going to substitute in, before I put in any numbers, I'm going to write this as the net force down here at the bottom. I'm going to write in the air resistance plus the force of gravity as my net force, divided by the mass. All right. So after doing some thinking, I realized the net force in this case is just these two vertical forces added together. So now I'm ready to put in my numbers. The air resistance, we said, was 295 newtons. That's in our given information. And the force of gravity, we calculated that for this particular skydiver. It was negative 540 newtons. Divide that by the mass of the skydiver, which is 55.0 0.0 kilograms. So the acceleration of the skydiver, we're going to first do 295 plus a negative 540, and that gives us negative 245 newtons divided by 55 kilograms. Put that into our calculator again. The acceleration of the skydiver is negative 4.45 meters per second squared. This is a reasonable answer because if there was no air resistance, the skydiver would fall at negative 9.81 meters per second squared. But because there is some air resistance, they're not going to accelerate as quickly. And so this number makes sense. If you get an acceleration that's way higher than 9.81, that means you might have forgotten a negative sign somewhere, or maybe you didn't calculate the weight properly. So one of the keys to this kind of problem is remembering that you can always calculate the weight of an object, especially one that's falling, because the weight is always just the mass of the object times 9.81 on Earth. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.